Hello, everyone. Good morning, or good afternoon, or good evening, or good middle of the night, depending upon where you may be. Hello, Wangamusa from Zimbabwe. Hello, Kapitan. Hello, NS. It's Thursday. Wow, we're already at the end of week 2. Hello, Ying. Hello, Kadist. I hope I'm saying your name correctly. Let's begin here by finishing up this sieve exercise. We started talking about this yesterday. We got most of the way done. Let's see here. So, we talk about the sieve of Eratosthenes. Hello, Esther, first time here. Glad you could join us. So, the sieve of Eratosthenes. I'm probably butchering his poor name. But, a technique known for several thousand years about finding primes. So again, the general idea, well, generate a list of the numbers between 0 and n inclusives. Mark the numbers 0 and 1 to be not prime. And as I said yesterday, we're not actually generating a list of the numbers. We're generating a list of true-false values. And more or less, we mark everything first initially as being true, except for 0 and 1. Right? This list of true-false values will it will contain our current belief as to whether a number is prime or not. And we update this list of true-false values. So we start with p is 2. Mark all the numbers of the form n times p, where n is bigger than 1. So if p is 2, we're going to mark 4 and 6 and 8 and 10 and 12, etc. to be not prime. I.e., we change all of those values in this list of trues and falses to be false. And then we repeat, we find the smallest number greater than p, where p starts as 2, which is not marked as being false. Set that equal to p and go back to step 2. And then we stop, and it says that we stop if there's no unmarked number greater than p and less than n plus 1. And so we wanted to break this process up into essentially 4 functions. So we had this first function, which we basically start with a list of trues, of all trues, of length n plus 1, except for the first 2 values, which are false. Because remember, the index in this list is going to correspond, to the appropriate number, right? Index I is referring to the integer I, and whether this number is prime or not. We wrote this function yesterday, or we wrote 2 versions of it. There's a mark false. It says here, takes a list of booleans and a number p, mark all elements 2p, 3p, etc. false. This is step 2. Write the find next, find the smallest true element in a list which is greater than some p. So i.e. has index greater than p. And this is the 3rd step. We wrote this list true and this marked false, and we were working on writing this find next. So I wrote 2 versions of this list true. One where we create a list of true values, and then we will just update these first couple of values to be false. Or another way, we used a list comprehension and a comparison. Right, we will iterate over the numbers from 0 to n inclusive and compare those numbers to 2. And this comparison right here will give us a true or false value for each of these numbers from 0 to n. Right, so either one of these functions will work. They will give us the same collection of true-false values. And we want the first 2 values to be false and all the other values to be true initially. And then we wrote this marked false function. So we take this list of true-false values and some integer p, and we're going to mark all of the multiples starting from 2p, so 2p, 3p, 4p, etc. So we could do this by using the range function, right? Start from 2p, go up to the end of this list, but do this in steps of p. So we'll have 2p, then we add p, we'll get 3p, add p, we'll get 4p, etc. Set all these values equal to false. All right, all these are multiples of the prime p, or the number p, and therefore these numbers are not prime numbers. And we need to write this find next function. So we are given this list of Boolean values, some index p, and we want to find the function which returns the smallest element which is not false and is greater than p. I mentioned this enumerate function yesterday. So enumerate. If you don't know about this function, you should. This is a good function to use, when it's appropriate to use it. It's a good function to use in like a for loop. Right, the enumerate yields pairs containing a count from start, which defaults to 0. However, we could start it from a different number, which we will do in this case. So enumerate, 0 and the first element in the sequence, this iterable, then 1 in the first and the next element, and 2, and so on. Right, and we could use that here because it's a nice, easy way to get a value like an index. So this Boolean list here is a Python list. We want to enumerate not over the entire list. We want to start the list where basically from index p plus 1. So we could use this enumerate for, let's make it explicit, for index and element in enumerate. I'm not going to start from the beginning of this list. I want to start from index p plus 1 and go to the end of this list. And remember, the enumerate normally starts from 0. I'm going to start enumerating from the value p plus 1. Right, because I want the index, right, which returns the smallest element. Basically, we want the index. Oops. Maybe this should be clarified. We want the index in the list, the smallest index, which is not false. I'm starting looking at my list from index p plus 1, and well, so we're looking for an index. So I'm going to start my enumerate from p plus 1 as well. And remember, this enumerate gives us a tuple, a index and the element at that location, at that index in this list. I want to check, is this element true? And I could do that just by, I don't have to compare this to true, I just have to say, is this true? Right, element right here is true or false. I don't have to compare it to true, it is already true or false. If this is true, I want to return my index. Right, this is what we're looking for. Return which, and the index, the smallest element greater than p, which is not false. If I get through my entire for loop and I've not found anything, I'm going to return the Python value none, special Python value. Right, find the smallest true element in the list which is greater than p. If there is none, well, I'm going to signal this using the special Python value none. There is no index greater than p, which is true. Right, so the idea, like, if we give this list of Booleans here and we want to start looking from index 3, I want index greater than p. So index 0, index 1, index 2, I should start checking here. This is index 3. Well, the find next right here should return index 3. Here, so index 0, index 1, index 2, we start checking from index 3, and this is false. There are no greater indices in this list, and so this should return none. Right, so remember, this Boolean list is a list of trues and falses. The idea here is, well, the value at index p is going to be true because that's the most recent prime that we found. And then we want to start investigating from index p plus 1 to find the next prime number. And again, this is what we're doing here with this enumerate. We're Normally, the enumerate starts from index 0, but we want to match the index we find with the index in this list. So this is why we start our enumeration from the value p plus 1. Right, remember, there's a lot of Python functions where they might have default values, but we could change those default values. Now, the last thing we need to do for this sieve function to work, well, we have our method which will initialize this list. We start searching from P, we call our mark false function to mark all the multiples of 2. No, the multiples of 2 are larger than 2 to be false, they're not prime. Then we find the next value in our list which remains true, set that equal to P and repeat. Right, this while loop will finish because at some point our find next function will return none. We continue this while loop while P is not none. At some point find next will return none. Then the last thing we need to do is we need to, find the list of prime numbers. So remember, this Boolean list will be a list of trues and falses. And we just want to find the indices in this list where these Boolean values are true. The indices, remember, correspond to the integers, starting from 0. All the values where this Boolean list is true are going to be prime numbers. So we need to fill in this prime from list function. Well, here again we could use the enumerate method. And we could do a list comprehension right here. So again, I'm going to use the variable index. So index for index, comma, element in enumerate Boolean list. So I'm going to enumerate this Boolean list, which, remember, again, will give me an index and an element, pairs, an index and an element from the Boolean list. Here, the enumerator is going to start from 0, and that's what I want, because we're enumerating over the entire list. But I only want to keep these indices if the element is true. And again, I don't have to compare elements to be true or false. Element already is true or false. Yeah, Patricia we could try and clear up your difficulties in a moment. Right, so this is going to iterate over this Boolean list, give me an index and a value which is true or false. I want to keep the indices where the element in this list is true, and those will give me all the prime numbers. So again, well, a test, so, assuming that this list is correct, this would say 0 is not a prime, 1 is not a prime. Those are both correct statements. 2 is a prime, 3 is a prime. Those are also both correct statements. 4 is not a prime. That is also correct. And remember, this right here is going to give us the indices in this list if that corresponding element is true. And so we'll check here. Yep, this prime from list returns a list of 2, 3. And we could define this sieve function, right, and then we check, right? This is checking, is the list of primes returned by this sieve method equal to the list of primes from our other method of getting primes? Yes. Right, S sieve of 1000 gives us, you know, this big list. Prime numbers, all the prime numbers less than or equal to 1000. And again, this is comparing how much time does it take for our sieve function to run versus how much time it takes for our getPrimes function to run. So this will run each of these functions, you know, a large number of times. So 962 microseconds, 6.06 milliseconds. 6.06 milliseconds is 6,060 microseconds. So the sieve is running about 5 times as fast as the getPrimes method. Right, 1/5 of the time for the sieve method versus the getPrimes method. And well, our final check, well, we submit this sieve function to the grader, and well, our sieve function gives us the correct answers. Patricia, what is it that you aren't understanding on this solution right here? Or indeed anybody else, what is it that you're not understanding in this solution? All right, so yeah, this is as I said, this sieve method is a very classical way of generating prime numbers. It's not going to help us as much if I want to, you know, generate the first 1,000,000 prime numbers. I mean, we could do it. It's going to take, you know, a bunch of memory to do so. So can I show again the sieve function? This is the one that was provided to us. Jayesh, yes, the essence of the sieve is in marking all the numbers that are multiples of p. Right, I say, oh, I start here with my first prime number is 2, and I mark all of the multiples of 2, which are larger than 2, to not be prime numbers. And then I would say, well, what is the next number that remains in my list which is still marked true? That next number has to be a prime number, right? The next number after 2, which is still marked true, that has to be a prime number. That will be 3. I'm going to mark off all the multiples of 3 which are larger than 3. So I would mark 6 and 9 and 12 and 15 and 18 and 21 and so on to be false. And then I would look through my list starting from 3, right? What's the next value on my list which is still true? That has to be a prime number because it's not marked off. So we're starting here with here Ying and mine. Again, this will depend upon maybe when you run it and so on, but this is microseconds, 10 to the power minus 6. This is milliseconds, 10 to the power minus 3. Yeah, the application is an optimization of the repeatable process. Yeah, right. We kind of want to not have to do a whole lot of testing for a particular number, right? A number will be marked false, perhaps by different prime numbers, but that's fine. Right, before in the get primes, we were having to test all of these numbers up to like the square roots. And here, in a sense, well, we're changing around that testing, in a sense, by finding a prime and marking off all the numbers which are multiples of that. So, again, if I run this, time it again, I'm going to get different results. Which again, will result, so here I'm getting microseconds and microseconds. This is 1/8 of the time, right? The running time is going to depend upon like what other load is running on the machine at the same time. Why is primes fast runs in only... Well, my get primes fast right here, so if I were to time this, oops, not time the definition. But remember, this is running over a smaller range. Right? If I wanted to do a fair comparison, I would need to run this over the same range. Time it get primes fast. Oh, this is, yeah. Oh, this only takes one. Why does Civ have a larger memory footprint? Well, it's because we're generating this Boolean list. Right, we're generating this Boolean list which has length n. We're keeping track of n true-false values. This is what this list true is generating for us right here. It's generating a list, well, it's actually a list of length n plus 1. we're generating this list of true-false values, which we're then manipulating. That's why the sieve method has a larger memory footprint than the get primes or the get primes fast method. So yes, you're pre-calculating the list and keeping it stored. Yes, that's what you're doing here. Because you're creating the Boolean list, you are then modifying the Boolean list and keeping the same, restoring the list right here. Right, you have this big long list, which the first two values start as false, all the other values start as true. And then you're updating some of these values in this list. You're turning true values into false values, but you're keeping the same length of the list. I'm sure if I run these again, I'll get different values. If we increased the value on sieve and get primes, well, sieve should definitely start winning. If I bump this up to 10,000 on each, of course, this is when my computer, things will probably lie or whatever. Right, the sieve with a limit of 10,000. All right. I'm still convinced at some point my sieve should start running quicker than the get primes fast method. It's just, yeah, that is the idea, is that as n gets larger, well, the sieve should start to win. Might be a matter of how quickly it's. So for 100,000, well, the sieve is taking 2.87 seconds. All right. Well, definitely the get primes method will lose, very badly to the sieve method. But yeah, the get primes fast should even start to lose, but it's a matter of, at what point. What sort of difficulties, Patricia? It's a bit hard to make suggestions. Are the videos making sense? Are you practicing every day? Right. A large part of learning how to program is to write some code every day. I mean, the only way you're going to learn how to code correctly is to write a lot of code, and you're going to get a lot of things wrong. But at some point, well, right, we hope that you'll be getting things more correct. This is definitely something where practice should help to make you better. The get prime computation is not playing really a part in data science. That's not the point of this exercise. The point of the exercise is to get you to write some functions to deal with iteration, right? To write for loops, to write conditional statements. Not everything we are teaching you is specifically dedicated to data science. We're first just trying to teach you Python. Bongamusu, what problem are you having in particular? I mean, it's a bit hard to say, to make suggestions when without something specific. You know, what's your error? What's the difficulty that you're having? It's, you know, your solution did not match the expected type. Well, again, that's telling you that this right here is your solution doesn't have the correct number of elements in the solution. It looks like you're submitting something where your solution had 5 numbers in it, and our grader was expecting your function to generate 8 numbers. Right? Your solution did not match the expected type 8 numbers. So the solution that your function was generating was not generating enough numbers. Your list only had 5 values in it, and the correct solution has 8 numbers in it. Specifically, it looks like you were missing the prime numbers 3, 5, and 7. Right, 2's a prime, 11, 13, 17, and 19 are also primes. But if you're generating all the numbers, you know, all the prime numbers between some lower and upper value, well, you're missing 3, 5, and 7. What other questions might you all have? What aspect can we consider when we want to write a code which runs faster? Well, basically, I mean, a few big things, right, is make sure that you're not doing repeated calculations, right? Unnecessary calculations. That's part of what the difference between this get primes and get primes fast is we are reducing the number of calculations. Right, this is prime fast is reducing the number of calculations needed to determine whether a number is prime or not. Right, the is prime method is doing a lot of unnecessary calculations. And we are removing a bunch of these unnecessary calculations by only going up to, you know, the square root of the number. So that's one of the main things, eliminate unnecessary calculations, or eliminate calculations which kind of duplicate, previous work. Well, the mini projects are, testing what you've learned, I guess. Yeah, you could copy my solution, I guess, but are you really learning something if you aren't trying these things out yourself? Why does list true return Boolean values? Because this right here is, that condition right here is is a Boolean condition. Right, this condition here is saying is I, excuse me, is I greater than or equal to 2. Right, if we were to say, think of rewriting as for I in range of 10, print I greater than or equal to 2. Right, so it's this condition right here that we are computing. Is 0 greater than or equal to 2? No. Is 1 greater than or equal to 2? Is 2 greater than or equal to 2? Yes. Is 3 greater than or equal to 2? Yes. So this is what we are computing right here. So we're computing this conditional value for everything in this range. And so this is why we get Boolean values. Right, this is just, rewriting this kind of for loop in a sense, right? I could create a list, I could append these values to this list. So Boolean values is an empty list. I could say Boolean values dot append. This will create a list of trues and falses. Well, and right, this is just the list comprehension version, I greater than or equal to 2 for I in range of 10. Oops, 10. Right, so this creation of an empty list and a for loop with an append, I could rewrite as this list comprehension. So what other questions might I answer for you guys? And hopefully you've looked at the object-oriented programming. I know that I've been seeing some questions, you know, on the board here about the DC Mini project. Yesterday I showed you my solution to the exercise, the insert exercise. Pythonic, do we have a link here? I think we have a link to the style guide. Imports, standard library. Ooh, these are good. So collections, this is a good method. For I in range, well, it's because for I in range 10, 10, if I is greater than or equal to 2, print I. Well, there's two things that are different, is because you're checking right here and you're only printing out those values where this condition is true. Right, let's compare. So I could write the two loops for I in range 10, print I greater than or equal to 2. Right, here I'm getting one value for one output for every value of I. If we count the number of outputs right here, we get 10 outputs. Right, index 0, or when I is 0, I is 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 10 values. I get one value for every value of I. So I have 10 outputs right here. Here I only have 8 outputs. Namely the numbers 2, 3, 4, 5, 6, 7, 8, 9. I only have 8 outputs. And I'm not printing out, I'm not checking whether this condition is true or false and printing out that result. I'm literally printing out the number I. Right, I'm printing I. I'm not printing whether I is greater than or equal to 2. Right, I'm checking this condition. First, I check this condition. Is this condition true or false? If this condition is true, then I execute this code right here. And I'm printing out the value I. If I wanted to, well, I could print out is I greater than or equal to 2 right here, and then I only get the values true, because I'm literally printing out only these true values, because I'm only printing out those values when this condition is true. Right, so this is always printing out this Boolean value regardless of whether that value is true or false. Right, there's no condition on my print statement right here. Here I'm first checking, is this value true? Well, if it is, I'm printing out true because that's what this evaluates to. This conditional statement results in a Boolean value, and I'm printing out that Boolean value, but I'm only printing out that Boolean value when that Boolean value is true. So this is why I always get true values right here. So, I mean, is this helping? Is this making this, better? Is this making things more clear? Right, because it's partly the difference between what am I printing. Here I'm printing a integer. Here I'm printing a Boolean value. Here I'm still printing a Boolean value, but the difference between this and this is here I'm always printing this Boolean value. Here I'm first checking this Boolean value and then I'm printing it out. Right, again, I think this is also part of what I mean by, practice and get your hands on the keyboard, right? If you're not understanding something, well, is there some code that you could try and write out which will help you, understand what's going on better? Right, I could say, I could print out, this will give me two values. I print out the value I, and then I'm printing out the value, this true-false value. Is I greater than or equal to 2? Well, certainly if I is 0, 0 is not greater than or equal to 2, and so this value is false. Right, you as I say to other people, well, try things out. You're unlikely to break things. This is how we learn things. Well, we write some code, we try some things out. But yeah, right, you should be trying out the mini projects yourself. Can you write the code for the mini projects, and come in and ask questions? Ask questions during the office hours, ask questions on the question board. I tried to do a pretty good job of monitoring the question boards and answering these questions. How do I resolve syntax error as seen below? Well, I'm not going to answer those. I'm not going to look at those questions at the moment, but when I'm done with the office hour, well, I will likely spend a few minutes looking at the question board, saying, well, can I give you a hint, a pointer as to what you're doing incorrect? So, I only know how to program because, well, I spend a lot of time banging away on my keyboard trying things out. I say, oh, what does the enumerate function do? I mentioned the enumerate function, right? For I, enumerate We can type in some strings here. Right, the enumerate right here is a generator in Python. It doesn't. It's waiting to be used. It's waiting to basically generate some output. I could get the output by wrapping this inside the list function, but I normally don't want to do that. I don't have to do that. I don't want to do that. Right? I would typically use enumerate in something like a for loop. Right? Enumerate generates tuples for index and element in enumerate. Print, well, the index and the element. Right, the index is the first number right here, and the element is, the elements, the individual elements in this list. And again, as I said, we could change the starting number. By default, this starts at 0. Let's start it at 3. Right, so my first index comes out as 3. When my next index comes out at 4, my next index comes out at 5. That's because I've started at 3. If I don't mention a start number right here, well, again, by default, the indices start at 0. And this is typically what we want, right? There's a reason why 0 is the default. It's because, well, if we're looking at a list, for example, well, the indices of the list start at 0. So yeah, this index right here is a variable. I could call this I if I wanted to do so, as long as I use I here. Right? I could use whatever variable names I want. For z, comma element, print z, comma element. So right, these are just variable names. I don't have to say the word element. I could say ELE. Right, these are all just variable names. In terms of finding the recordings, there's 2 places. So on your control panel, if you go under video links and scroll down to the bottom, you'll find an office hour playlist. This is an office hour playlist on YouTube. And here you get all of the office hours. Right, one going on live right now, one at the bottom. You could go under video downloads, go under office hours videos. I will upload the videos here, but I only upload the videos once a week. That's why there's only the first 4 office hours here, because like later today or tomorrow, I will upload the videos for this week. But if you want the live, up-to-date list of office hours, use the YouTube playlist. Because these will be added, basically every day I stick the office hour on the playlist. I mean, right, so my main point I was trying to make, well, if you learn about something new, well, then you can spend a bit of time kind of playing around with it, trying it out. How does this thing work? Or go online and, do a bit of searching. Will these videos be available always for us? Yeah, the office hours videos will be available. The video links right here, they will be available. The videos on YouTube aren't going away. The videos in the shared folder, for the lectures, right? Not for the office hours, but these, might go away at some point. But the video should be on YouTube, right? You can, of course, download these videos. Yeah, that's a question that you all might have your own answer for. How many hours are you spending on the course? Well, of course, you want to watch the videos. You want to try, the exercises. You want to work on the mini projects. Right, this course will be better for you if you keep up during the 8 weeks. We're out of time today, so I will wish you all a pleasant weekend. More videos will be made available soon for next week. So stay tuned for that. I wish you all a pleasant weekend, and I will see you next week. Stay safe, be well, and be nice.